Okay, hello everyone. I welcomes to all once again in our lecture series on error function. Last class we have been discussed this topic. That was our lecture number 1, definition and characteristics of error function and complementary error function. In this class, that is your lecture number 2, we are going to discuss derivative of error function and complementary error function with corresponding questions. Okay, so let us start. Here, these things already we have been discussed in our lecture number 1. That is your error function is represented like this: 2 by root pi 0 to x e to the minus t square dt, and complementary error function represented as 2 by root pi x to infinite limit e to the power minus t square dt. Characteristics we discussed, 7 characteristics we discussed in detail in our last class. Okay, in this class we are going to discuss derivative of error function and complementary error function with corresponding questions. Okay, first we have to evaluate derivative of error function with respect to x, d by dx of error function x. Okay, here solution starts. To evaluate the derivative of error function with respect to x, we have to remember the rule of differentiation under integral sign. First I am going to write in general what is that rule of. We have to remember rule of differentiation under integral sign. Here we are no need to prove this one. We have to just remember the result and we have to apply rule of differentiation under integral sign. In short, it is called as DUIS. Okay. According to this rule, d by, in general I am writing d by d alpha of a integral like this, lower limit is your a, upper limit b, f of t dt is equal to, here this is your d by d alpha. So first term will be a to b del by del alpha of f of t dt. Then second term will be f of upper limit. Here upper limit is your b, f of upper limit into differentiation of upper limit with respect to alpha, db by d alpha, plus minus f of lower limit is your a, then into differentiation of lower limit with respect to alpha. Okay, in general this is your rule of differentiation under integral sign. You just remember this one. Here we are going to use this result. No need to prove this one. To prove how to this value equal to this much, for that I will be make a separate video later. Okay, here we are going to use this result. If we have a function like this integral function a to b limit f of t dt differentiation with alpha, the first term will be a to b del by del alpha of this f of t dt plus f of higher limit, then into derivative of higher limit with respect to alpha minus f of a derivative of lower limit with respect to alpha. Okay, this is your d alpha. Here in our case we have to differentiate d by dx. That implies d by dx of error function x is nothing but d by dx of integral form of error function is nothing but 2 by root pi 0 to x e to the power minus t square dt. Okay, or we can write this is nothing but 2 by root pi is the constant taken outside. D by dx of 0 to x e to the power minus t square dt. Okay, so here you just compare differentiation of this integral and differentiation of this integral, here with respect to alpha, here with respect to x. Here f of t is nothing but e to the power minus t square. Here lower limit a, here lower limit 0, upper limit b, here upper limit x. Okay, we have to just apply duis. Now apply duis, we get here we have to apply the duis differentiation under integral. So what will the value? That implies d by dx of error function x, which will be equal to 2 by root pi is there, you just write as such. Then first term will be integration lower limit to higher limit 0 to x, then del by here del by del x, here del by del alpha, and here we have write del by del x of the function is your e to the power minus t square integration with respect to t. Then second term is your plus f of higher limit x, f of x, then differentiation of higher limit with respect to x. Okay, higher limit is your x, then minus f of lower limit is your 0, here lower limit f of a, so here lower limit is your how much, is your 0, so f of 0, then differentiation of lower limit with respect to x, this much, right? That implies what we can get, that implies d by dx of error function of x will be equal to 2 by root pi. Here you can see differentiation with respect to x, and this is this value is function of t only, so this value will be 0, right? Plus f of x, here f of x value will be how much, here f of t we have how much, e to the power minus t square, so f of x will be how much, e to the power minus x square, right? So here f of x will be e to the power minus x square, and differentiation of x with respect to x will be 1, and this value f of 0, here f of 0 we can get e to the 0 equal to 1, but this value d by dx of 0 is nothing but 0, right? So finally how much you can get, differentiation of error function will be equal to 2 by root pi into e to the power minus x square. Okay, so this will be the answer. Now we are going to go for differentiation of complementary error function. Second one, we have to find out, evaluate d by dx of complementary error function. Okay, same procedure we have to apply, same procedure duis we have to apply. So that implies we know d by dx of, here solution starts, error function, complementary error function is equal to, we can write d by dx of, here 2 by root pi, the limit will be changed. Here in case of complement error function, the limit is your 0 to x, but for complementary error function it will be x to infinite. Okay, x to infinite e to the power minus t square dt. Okay, here 2 by root pi is the constant taken outside. D by dx of, we have to write d by dx of this integration x to infinite e to the power minus t square dt. Okay, okay. Now we have to apply. Now apply differentiation under integration sign rule. We get what we can get. That implies d by dx of complementary error function of x will be equal to 2 by root pi is a constant taken outside. If we are going to apply duis here, then this will be integration limits x to infinite, then del by del x of e to the minus t square dt plus f of higher limit is your infinite into d by dx of higher limit, that is your infinite, minus f of lower limit is your x into d by dx of lower limit, that is your x. Okay, okay. That implies we can found d by dx of complementary error function x will be equal to 2 by root pi is there here. Here del by del x of e to the t square will be equal to 0 because this is purely a function of t. So derivative with respect to x obviously it will be 0. So this term will be 0. Plus here you can see we have f of t is nothing but e to the minus t square. F of infinite, that means e to the minus infinite is nothing but 0. So here f of infinite for this case is 0. And differentiation with respect x infinite of infinite, no need to write because this term will be 0. And f of x, if I am going to consider f of t equal to e to the minus t, and corresponding f of x will be e to the minus x square. So here f of x will be e to the minus x square, and derivative of lower limit, that is your x with respect to x, equal to 1. Okay, okay. So finally we got the answer as derivative of error function with respect to x, complementary error function with respect to x, derivative with respect to x we found as 2 by root pi. Here minus is there, minus 2 by root pi into e to the minus x square. Okay, you just remember this one. It will be this result also required to solve other questions. Okay, maybe this value will be asked directly for 1 mark in your exam. You just remember, if I'm going to compare the two results, differentiation with respect to x of error function and complementary error function, only minus sign is extra in this. Here 2 by root pi e to the minus x square, here minus 2 by root pi e to the minus x square. Now we are going to go for our third question. Now we are going to uh, evaluate some questions based upon this differentiation derivative of error function. First we have to find out evaluate. Procedure is same. Evaluate error function of ax. Okay, ax. Evaluate d by dx of error function of ax. Procedure is same. Here solution starts. D by dx of error function of ax is written in the integral form as d by dx is there, 2 by root pi 0 to ax e to the power minus t square dt. 2 by root pi is the constant, can be taken outside. D by dx of integration from 0 to ax e to the power minus t square dt. Here f of t is your e to the power minus t square, and higher limit is your ax, lower limit is your 0. Okay, So that implies here we have to apply the rule, DUIS rule. Now apply the DUIS, differentiation under integral sign rule, on above integral, means this integral, on above integral we get. That implies d by dx of error function of ax will be equal to 2 by root pi is the constant written as such here. By applying DUIS here, according to DUIS, differentiation with respect to this one alpha, then second term f of higher limit, differentiation of higher limit, then third term is your f of lower limit and differentiation of x of the lower limit. Okay, so here first term will be how much? Integration limit 0 to ax is there, del by del x of e to the power minus t square dt, the first term. Second term is your f of higher limit, here higher limit is your ax, into d by dx of higher limit. Okay, minus f of lower limit into d by dx of lower limit. That's it. You just practice 2 or 3 questions, you will get the confidence. That implies d by dx of error function of ax will be equal to 2 by root pi. Here this is the differentiation with respect to t function only, so this term will be 0, plus f of ax. See, f of t is nothing but we have e to the power minus t square, so f of ax will be how much? E to the minus a square x square. So we have to write this one, this is your e to the minus a square x square, into d by dx of ax is nothing but a plus minus, here f of 0 will be e to the 0 equal to 1, but this value d by dx of 0 is nothing but 0. So finally how much we got the answer? That implies d by dx of error function of ax equal to, here this term will be 0, first term will be 0, this a is the constant, we can write 2a by root pi into e to the power minus a square x square. Just remember this one, this is required to solve other different type of question. I suggest you just remember this one. Okay, this result. Now we are going to go for evaluation of derivative of complementary error function. So fourth one is your evaluate d by dx of complementary error function of x, complementary error function of ax. Complementary error function of x already we have been evaluated. Okay, here complementary error function of ax equal to, here I'm going to write the answer, you do by yourself. Okay, this answer will be minus only minus 2a by root pi e to the power minus a square x square. Just do by yourself. This is the assignment for you. Same procedure, already evaluation of a complementary error function here I done in the question number 2, and here I done the error function differentiation of error function of ax. Similar way you can do complementary error function of ax, same procedure. Okay, so you just do by yourself. This is your assignment. Okay, so answer you can get only minus here. If I am going to compare this question and this question, here only minus is the difference. Okay, okay. Now we are going to go for our next question. Question number 5. Find the differentiation of d by dx of error function of a x to the power n. Okay, a x to the power n. Same procedure. You just apply the DUIS and you can get the answer. Here d by dx of error function of a x to the power n can be written in this format as d by dx of, here error function means 0 to here a x to the power n e to the power minus t square dt. Okay, okay. Sorry, here I forgot to write 2 by root pi. So 2 by root pi constant taken outside, we have to find out this much value, d by dx of integration limit 0 to a x to the power n e to the power minus t square dt by using DUIS. Now apply DUIS, we get that implies d by dx of error function of ax to the power n equal to 2 by root pi is the constant, already is there, just written as such. First term by using DUIS, first term will be integration limit a to ax to the power n, sorry 0 to ax to the power n del by del x of e to the power minus t square dt. Here you can see, here we written error function of ax to the power n. So here this is the function of x. Okay, so as this is the function of x, here we have to consider differentiation with respect to x. Okay, you just keep this in your mind. Now first term will be what? f of upper limit is your ax to the power n into d by dx of upper limit ax to the power n minus f of lower limit into derivative of lower limit with respect to x. Okay, okay. So this will be equal to 2 by root pi is there. First term obviously it will be 0. Second term, here we have f of t is your e to the minus t. F of ax to the power n will be how much? It will be e to the power minus ax to the power n whole square. So it will be e to the power minus a square x to the power 2n. Okay, so same thing we have to write first. This value f of ax to the power n will be e to the power minus ax square a square x to the power 2n. Okay, then differentiation of this one will be a is the constant. Okay, taken outside a, x to the power n will be how much? N into x to the power n minus 1. Okay, okay. Then minus this value, obviously it will be 0 because d by dx of 0 will be 0. Got it? Now finally how much we can get? That implies d by dx of error function of ax to the power n will be equal to 2 by root pi, here 2an, we can write 2an into x to the power n minus 1 into e to the power minus a square x to the power 2n. So this is the to n. This is the answer. Okay. Now we are going to go for our next question. Uh, Here, question number 6. Evaluate. Same. I'm going to give you that you have to do by yourself. Differentiation of complementary error function with respect to x. Complementary error function of ax to the power n. Here complementary error function is there. And its answer will be just minus of 2an by root over of pi into x to the power n minus 1 into e to the power minus a square x to the power 2n. Okay, you just do by yourself. This is your assignment for you. Okay. So here I am going to stop this lecture. In this lecture we discussed differentiation, derivative of error function and complementary error function with corresponding questions. Okay. In our next class we are going to discuss integration of error function and complementary error function. Okay. So thank you so much for watching this video. Thank you.